Okay, here we go. Here's our first video. Now, don't forget, okay, for all videos that you view, make sure you take notes in your notebook on the right-hand side of the page, okay, and complete all the review questions online. So, here's our first video, 1-1. Chemistry is a physical science and matter and its properties. Okay, now, a couple things that you're going to notice for the videos. One, title will be at the top, and below it will be the topics that are going to be covered. So, first thing, looking at chapter 1, matter and change. A lot of these things you guys should already know. So, what is chemistry? Well, what are we studying? We are studying composition and structure and the properties of matter. Remember, chemistry is studying matter, okay, and the changes it undergoes. So, chemists will typically ask questions like, what's a substance made of? What does its internal arrangement look like? How does it behave if the substance is heated, cooled, if it's mixed with another substance? Will it react? Will it undergo chemical reaction? Will nothing else happen to it? Okay? And most importantly, why is it doing it? Now, instruments are routinely used to extend our ability to observe and make measurements, which are pretty much the basis for any scientific discovery. Some common ones are things like a scanning electron microscope. And the way this works, a regular microscope shoots light, which is made up of photons, towards an object, and it bounces off the object. Now, if the object is too small, the light basically just bends around it and you don't get any reflection. By using electron microscopes, you're now shooting an electron beam at the substance. This gets shot back, and a computer will process it and give you an image of the object. Okay, so here's a basic little diagram of electron microscope. Okay, it does have things like an electron gun and a lens, okay, but instead of light going through and basically illuminating the object, the electrons hit the object and will bounce off and get shot back to the lens. Okay, and here's some couple pictures of images of objects that were taken with using electron microscope. Okay, another type of thing that's commonly used is a method called X-ray diffraction. And basically what you do is you shoot X-rays, which are sort of just like light, except they're a different frequency. They go through an object, and as they go through, depending on what the internal structure looks like, it comes out and it scatters in different patterns. So, basic idea is we have something like an electron, something that shoots out electrons, X-rays. It'll be focused through a lead shield. It goes through the object, and the object can have a crystalline structure, basically just like a cube here. Now, when it comes through and hits this plate, it doesn't look like a cube. But the idea is, if you shoot it through something else that has this kind of structure, you should also get this scattering pattern. So, if you have a whole bunch of different standards that you shoot the electrons through it, or the X-rays through it, and you see what happens here. You now have a bunch of different little templates that you can use. So if you have it on loan, shoot the X-rays through it, look and see what kind of pattern you have, compare it, and that'll tell you what the structure looks like. Okay, now, chemistry does study matter, but it's broken up into a bunch of different branches. Okay. Organic chemistry. Now, this area, a lot of people use the term organic today, but it's not necessarily following the chemical definition of it. Basically, organic chemistry just simply studies carbon compounds. Okay? The petroleum industry, because petroleum is carbon-based, fossil fuels, heavily involved with organic chemists. Okay? Inorganic chemistry is basically anything that is not going to have carbon in it. Okay. People always looking to try and make new metallic alloys, new combinations of metals to make them lighter or stronger, things like that. So organic chemists or inorganic chemists will be studying these types of substances. Okay. Physical chemistry. You're looking for changes in matter and energy. Okay, so fuel cell technology. How do we create better sources of energy, better batteries, different types of batteries? Okay. Analytical chemists. If you watch shows like CSI or anything where they're doing crime labs, these are the people who basically are trying to figure out what's there and what is the substance made up of. Okay. Biochemist, as the name implies. Bio is dealing with living substances, and chemistry looking at matter. So study of the substances and the processes that occur in living things. Okay. So pharmaceutical companies will employ a lot of biochemists. Okay. And theoretical chemists. These people use math and computers to understand the principles behind the observed chemical behavior and to design and predict the properties of new compounds. This is pretty much where you find research chemists. A lot of them are employed by universities. Some of them will be employed by private companies. Okay, now, some definitions. What's a chemical? Chemical is basically anything that has a definite composition. In other words, you can write a chemical formula for that substance. Chemicals are basically either just one of two categories. They're either elements or going to be compounds. Water has a definite chemical formula to it, H2O. Sugar also will have a different chemical formula, salt, NaCl. Okay, all these things are chemicals. Now, couple more things. Types of research and development. Hey, basic research. These are things that your research scientists will be involved in, carried out for the sake of increasing knowledge. What happens? How does it happen? Why does it happen? Okay. The people who create new elements or trying to create new elements. These are people just employed in doing basic research. Okay. Applied research. You're carrying it out to solve a specific problem. Okay, so maybe an inorganic chemist. How do you create lighter, stronger materials for automobile bodies? Okay, and technological development involves the production and use of the products that improve our quality of life. Okay. Now, technological development already takes substances or technology that is, or science that is there, and puts it into use. Okay. So manufacturing and producing efficient hydrogen fuel cells for cars. Fuel cells have been around for 30, 40 years right now. The Apollo moon missions use fuel cells. Okay. And basically a fuel cell basically just uses a chemical reaction to produce electricity. Now, why don't we use those in cars? Main problem? It's too expensive and not very efficient. So this is where technological development comes along. Okay, now, our next section, matter and its properties. Okay, matter, anything that has mass and volume. Okay, now, what is mass? Mass is a measure of the amount of matter that's there. But wasn't matter the amount of mass? Okay, so, not a real good definition. A better one is probably going to be this one right here. A measure to the resistance of an object to change in a state of motion. In other words, the more mass you have, the harder it is to change your state of motion. Okay, volume, just the amount of three-dimensional space an object occupies. Okay, basic building blocks of matter. Atoms. These are the smallest units of an element containing the properties of that element. Okay, what's an element? It's a pure substance made up of only one kind of atom. Okay, and examples, all the things that are on your periodic table. Okay, a compound has two or more atoms that are chemically bonded together, two or more different elements. Okay. Molecule, these are things that will be the smallest units of certain types of elements and compounds, and they retain all the properties of that element or compound. Okay. So, examples, water, H2O, this is a molecule. C12H22O11. Remember this formula here. It's going to come up a bunch of times. This is sucrose. Sucrose is basically just table sugar. Okay. Now, properties and changes in matter. We can measure properties of matter and classify them as either an extensive property, And an extensive property depends on the amount of matter that's present. So an extensive property would be something like the volume. If you measure the volume of the object and you change the object, you make it bigger or smaller. If this measurement changes, then it is an extensive property. Mass, energy in the substance. Okay. There are some properties of an object that no matter how much or how little you have, the property doesn't change. These are known as intensive properties. Okay. These would be things like the boiling point. Boiling point of water, 100 degrees Celsius. Doesn't matter how much or how little you have. That's always the temperature that water boils at. Same as the melting point, the density of the objects also. Color would be an intensive property also. Okay. Physical properties. These are characteristics that you can observe or measure of a substance without changing the identity of a substance. So these would be things like the mass. You can observe the mass, the length, the color, the density of an object, and it doesn't change the properties of the object. The object is still the same thing. Okay. A physical change is a type of change where you do something to the object, to the piece of matter, and it does not change the identity of the substance. You can change a physical property. You can change its mass, change its volume, but the substance is still the same substance. Okay. Any phase change is a physical change. Melt ice. You still end up with water. You started with water, you end up with water. This is still a physical change. Okay. Now, for different phases of matter, you actually have 4 phases of matter: solids, liquids, gases, and plasma. Okay. Plasma is actually something that is a high energy state, where basically the atom has its electrons ripped away. Okay. Now, shapes. For a solid, definite shape, definite volume, compressibility, pretty much none. You take a solid, try and press it together, the particles aren't going to get any closer. Okay. Liquid does not have a definite shape. It's going to take the shape of its container. If it has no container, it's basically just going to spread out. Okay. Its volume, though, is always going to be exactly the same. If you have 1 gallon of water in a gallon container, it takes the shape of the gallon container. You pour it on the floor, it's now going to take the shape of the floor. Okay. Compressibility, pretty much none also. The particles are really close. You can't push them any closer together. Okay. A gas, you can actually change its volume. Gas, like a liquid, will take its shape of its container, the volume of the container. Compressibility, though, because the gas particles are far apart, you can actually make a gas get bigger or smaller. Okay, and plasmas, shapes and volumes of the containers. Compressibility, slight. It's really high energy, though, so for the most part, it's going to be compressed. Okay, chemical properties. This relates, unlike a physical property, this relates to a substance's ability or inability to undergo changes that transform it into different substances. In other words, how it reacts. Okay, so oxygen reacts or combusts with hydrogen. That is a chemical property of oxygen. It will not react with helium. That is also a chemical property of oxygen. Okay, and helium's chemical properties are that it does not react with oxygen. Okay. Now, a chemical change, unlike a physical change, you have to change the substance into a different substance. Yes, you can change physical properties, but you also change the chemical properties. So the substance has to turn into a different substance. Okay. Example, iron rusting. Iron, when it rusts, it turns into some form of iron oxide. Chemically, it's going to be different. Okay. The substances that you start with in a chemical change, these are known as the reactants. The new substances that you produce are going to be called your products. Okay, and we write chemical reactions this way simply. List your reactants on the left side. The arrow over here means yields or produces. So reactants yields or the reactants produce the products. Okay, iron and oxygen would be your reactants. Iron oxide would be your products in the rusting reaction. So your reactants yields products. Okay, energy and changes. All changes, chemical and or physical changes, will involve energy. Okay, the energy can be in a lot of different forms. The substances will either take in or give off energy in the form of light, heat, could be mechanical. Mechanical energy is basically just movement. Okay, can be absorbed or released by the system undergoing the change. Okay, now we have a law. Energy is neither created nor destroyed in a chemical or physical process. Okay, the energy can be changed to a different form, but the total energy which you started with and what you ended up with has to be exactly the same. Okay, this law is known as the law of conservation of energy. Okay, now, little question. Okay, in the sun, matter is actually destroyed. Okay, we actually have another law that says mass or matter cannot be created or destroyed. Okay, in a chemical or physical process. And the sun actually does create energy. Okay, now, why doesn't this violate the law of conservation of energy and also the other law called conservation of matter? Okay, it's a simple reason. If we go back and we look, it says this has to be a chemical or physical process. Okay, here, the process of fusion is not a chemical or physical process. This is a nuclear process. Okay? And over the course of the year, you'll learn the difference between a chemical process and what a nuclear process is. Okay? So, fusion does not destroy or does not violate this law simply because it doesn't apply. It's not a chemical or physical process. Okay? Now, why is this actually happening? How come you can actually take mass and destroy it and change it into energy? Well, there is some guy named Einstein or something like that, and he said, well, mass is actually a form of energy. So here's your review question. And make sure you answer this online. Click on the link that's on the webpage. Which branch of chemistry would study sugar conversion into alcohol? Is it physical chemistry, organic, inorganic, analytical, or theoretical? Okay, remember your answer and answer it online.